All right, hello everyone. Welcome to my channel. My name is Thomas, and I do educational videos on this channel. Today is, I think it's the 175th video that we've done on the reciprocal system of theory. And this is a system of theory. It's a theory of everything that was developed by Dewey B. Larson. Back in the 20th century. He died back in 1990, but not before writing many books on the subject and many articles. He got a little bit of a following, and a few other people have followed him along since then and written a few things that we will go over very shortly. Not today, but in the coming months. And I think it's a great system. The basic idea behind the reciprocal system is that we live in a universe of motion. Now, when he first published his findings back in the late 1950s, he used the term space-time rather than motion. And before he died, he also he continued to use the term motion, but he also called it change in 3 dimensions. So you can think of it in any of those 3 terms, really. We live in a universe of change. Okay, things are changing. We don't live in a static situation, in a situation where things are the same as they were 2 seconds ago or 2 hours ago or whatever. Things are always changing. So other people have come up with that idea that the universe is made out of motion. But what distinguished Larson is that he defined emotion. He defined it as the relationship between space and time. And that's utterly logical. The only real understanding we have of motion is really speed. The car is moving at 20 miles per hour, 20 miles of space in 1 hour of time. Space over time, that is speed, space over time. But it turns out that really all like physical quantities have time and space as their sole constituents. But as he said, change in 3 dimensions. So space and time both have at least three dimensions. He calls that their coordinate aspects. So we kind of understand coordinate space, X, Y, Z coordinates, Euclidean coordinates. So if you're graphing something, you got your x-axis and your y-axis, and then you have your z-axis also in 3 dimensions. Those are the coordinates of space, but time also has their coordinate aspects. Now, those coordinate aspects are not space-like, they are time-like, but it's still coordinate, 3 or more dimensions. And then space and time also have their clock aspects. We understand the clock in terms of time. Time is flowing, time is progressing, time is always getting later and later and later. But space is also flowing and progressing and getting farther and farther and farther apart. Larson calls this scalar motion. Clock time and clock space is a scalar motion, a motion that has a magnitude, but it has no particular direction, or you could think of it as all directions. And you envision this by using a balloon and a magic marker. You put a bunch of dots on the balloon with the magic marker, and then you blow up the balloon. All of the dots are moving away from each other, but in no particular direction, or in all directions. And this is what's called an outward scalar motion. You suck in the balloon, and then you have an inward scalar motion. This was also detected by the Hubble telescope, Could have been a fraud, I guess. But all they discovered way back in the 1920s that all of the distant galaxies are moving away from each other. That is the progression of space. Now, what also occurs with both time and space is they both come in only discrete units. There is no continuity of time and space. They have a minimum unit, and that is 1 unit of space is 4.56 times 10 to the minus 8 meters, and the 1 unit of time is 1.5 times 10 to the minus 16 seconds. So that's 6 quadrillion per second, and 20 million per meter in terms of space. So they're very small, but they are not continuous. They are in chunks. And 1 unit of space in 1 unit of time is the speed of light. So the speed of light is really like the midpoint of the universe, which contradicts Einstein, who says that the speed of light is the maximum speed of the universe. That's because Larson didn't know about the entire half of the universe that's moving faster than the speed of light. Larson calls this the cosmic sector. And in that half of the universe, the speed of light is actually the slowest speed in the universe. And so that speed of light outward in all directions is what Larson calls the progression of the natural reference system. This is the natural reference system. When we have a reference system, our reference system is generally zero, like from stationary, and then something starts moving and you say, oh, it's going faster, or if it's backing up, then it's going slower than zero. But the reference system that nature or God or whoever is using is the natural reference system that is outward at the speed of light in all directions. If it's going slower than that, then it is a material phenomena. If it is going faster than that, then it is a cosmic phenomenon. Okay, now today we're looking at Larson's 1979 book that's called Nothing But Motion, which is primarily on physics, a little bit of organic chemistry as well. And we are in chapter 10 that is called Atoms. And we just started this chapter, so I'm going to back up by 2 paragraphs and read those again and then get into the bulk of this chapter. Now, atoms are, they are rotational combinations. Larson really says that there are 4 kinds of motion. There is your translational motion, there's your vibrational motion, there's your rotational motion, and then there's your rotational vibration. And these can come in 1, 2, or even 3 dimensions. And that is how an atom gets built up. It gets built up by combining different kinds of motions. And now in the second paragraph, he's going to be giving you a visualization. And I think it's really important that you kind of go over this very slowly, like rewind me a few times and listen to it until you can make this visualization and you can see how there are really 2 photons at the core of every atom. Now, the photon is really a simple harmonic motion. That's a wave. Now, for Larson, the simple harmonic motion comes from a combination of a translational motion and a vibrational motion, normal to or 90 degree angle off of the translational motion. So the motion goes along, but at the same time it's going up and down and up and down, and so that creates this wave-like motion. Now, a lot of Larson's followers have disagreed with that and have said that that the photon comes out of a birotation. When you combine two counter-rotating bodies or two counter-rotating motions, then you also get a sine wave. So when Larson's talking about it here, he's talking about it in terms of that he understands, but others, especially Dr. KVK Nehru, who came up with the idea of birotation, and also Dr. Bruce Perrett, have gone along on a different track there. And we will be looking at those scholars as well later on. Okay, chapter 10, atoms. In some respects, the combinations of motions with greater rotational displacement, those which constitute the atoms of the chemical elements, are less complicated than those with the least displacement, the subatomic particles, and it will therefore be convenient to discuss the structure of these larger units first. Geometrical considerations indicate that two photons can rotate around the same central point without interference if the rotational speeds are the same, thus forming a double unit. The nature of this combination can be illustrated by two cardboard discs interpenetrated along a common diameter C. The diameter A perpendicular to C in disk A represents one linear oscillation, and the disk A is the figure generated by a one-dimensional rotation of this oscillation around an axis B, perpendicular to both A and C. Rotation of a second linear oscillation, represented by the diameter B, around axis A, generates the disk B. It is then evident that disk A may be given a second rotation around axis A, and disk B may be given a second rotation around axis B without interference at any point, as long as the rotational speeds are equal. Okay, so you want to kind of go over that in your head a little bit until you can kind of grasp it, the image there. Okay, the validity of the mathematical principles of probability is covered in the fundamental postulates by specifically including them in the definition of ordinary commutative mathematics, as that term is used in the postulates. The most significant of these principles, so far as the atomic structures are concerned, are that small numbers are more probable than large numbers, and symmetrical combinations are more probable than asymmetrical combinations of the same total magnitude. For a given number of units of net rotational displacement, the double rotating system results in lower individual displacement values, and the probability principles give them precedence over single units in which the individual displacements are higher. All rotating combinations with sufficient net total displacement to enable forming double units therefore do so. To facilitate a description of these objects, we will utilize a notation in the form A-B-C, where C is the speed displacement of the one-dimensional reverse rotation, and A and B are the displacements in the two dimensions of the basic two-dimensional rotation. Okay, so you have a disk to represent a one-dimensional rotation, and then when you rotate that disk, it creates a sphere, and that is your two-dimensional rotation. Now, his notation, A-B-C, is basically running parallel to the atomic number in the periodic table. Okay, so you would just you would use that notation. So really, every different atom is going to have a unique combination of numbers there of the A dash B dash C. Every different atom, every different kind of atom. So if you have oxygen, that will have one particular A dash B dash C notation, whereas if you have carbon, it will have a different A dash B dash C. And it turns out that that C can be positive or negative. It can, and so that kind of increases the permutations there. Okay, back to Larson. Later in the development, we will find that the one-dimensional rotation is connected with electrical phenomena, and the two-dimensional rotation is similarly connected with magnetic phenomena. In dealing with the atomic and particle rotations, it will be convenient to use the term electric and magnetic instead of one-dimensional and two-dimensional, respectively, except in those cases where it is desired to lay special emphasis on the number of dimensions involved. It should be understood, however, that designation of these rotations as electric and magnetic does not indicate the presence of any electric or magnetic forces in the structures now being described. This terminology has been adopted because it not only serves our present purposes, but also sets the stage for the introduction of electric and magnetic phenomena in a later phase of the development. Okay, so he's going to be using these terms, but that doesn't necessarily imply that any magnetic or electric forces are at play in the discussion. And again, this is a difficulty of the reciprocal system, is that Larson has to come up with a language to describe what he's trying to impart to you, because the language isn't already there. These are completely new concepts, and so the progenitor of those concepts has to provide a language to communicate those, and sometimes that language isn't as smooth as maybe, or slick as maybe an older theory that's had some time to work out the kinks. There are some terminology, some terms that Larson used didn't work out as well as others, and he sometimes changed the terminology after a few years or whatever, after getting some comments from some readers and so on. Just take his terminology and just try to remember what it is. Eventually, maybe you can change it if you don't like it. But that's what he's going with. He's using electric and magnetic. And I know that, at least for one friend of mine, this served as kind of a big sticking point, because he was an adherent of legacy science, and he sees these terms and they set off ideas in his head about what they are, and that they're not always one and two dimensions. But that's the way that Larson is rolling here. One-dimensional is electric, two-dimensional is magnetic. But that's not implying those forces. That's just the description of these one- and two-dimensional rotations. Where the displacement in the two magnetic dimensions are unequal, the rotation is distributed in the form of a spheroid. Okay, not a sphere, but a spheroid. A sphere-like. It's like an like oblong in one dimension. In such cases, the rotation which is effective in two dimensions of the spheroid will be called the principal magnetic rotation, and the other the subordinate magnetic rotation. When it is desired to distinguish between the larger and the smaller magnetic rotational displacements, the terms primary and secondary will be used. Where motion in time occurs in the material structures now being discussed, the negative displacement values of this motion will be distinguished by placing them in parentheses. All values not so identified refer to positive displacement or motion in space. Now again, Larson flips it. He calls motion in space the positive displacement, even though technically it's negative because it's slower than the speed of light. The material sector is slower than the speed of light, whereas the cosmic sector is faster than the speed of light. So you would think that the cosmic sector would be positive, but he calls the cosmic sector negative because we basically live in the material sector. This is where we make our observations. This is where we make our measurements. This is what we're accustomed to. This is the cosmic, over here is the cosmic universe. This is the universe that Einstein didn't know anything about and legacy science doesn't know anything about. And so he accommodates by changing the positive and the negative around so the positive is what we're used to. The positive displacement is called motion in space. Again, Larson is the person that has to come up with the terms here, and you just have to give him the benefit of the doubt. He put a lot of time into thinking about this, and so he probably knows what he's doing when he's coming up with this terminology. And if he doesn't, then he's probably willing to change it. Okay, we didn't get too far today, but we are plugging away on chapter 10, and we will talk tomorrow and resume from where we are. Thanks for tuning in. Have a great day.